We're looking at operations of functions this morning with a little different notation than you may have seen before. So we know how to do f plus g of x, but another way to write that is like this, f plus g of x. And remember that this of x is not multiply. It's the function notation. Wow, can't spell. Okay, and then the rest are true for the other operations. So let's go ahead and look at 1a. F plus g of x. Another way to write that would be f of x plus g of x. So I'm literally just taking the two functions and adding them together. So f plus g is equal to x squared plus 9 plus 3x plus 5. I can go ahead and simplify. So x squared plus 3x plus 14. The next one, g minus f. We have to be careful. This would be, the order matters for subtraction, so just be careful there. Is equal to 3x plus 5 minus the quantity of f, so x squared plus 9. So the negative distributes in, and we get negative x squared minus or plus 3x plus 5 minus 9. Just reordered them. Sorry if that was a little wonky. Okay. Next, f times g. Does the order matter? Nope. So this is f of x times g of x. Multiplication, you can multiply 1 times 2 or 2 times 1, you still get the same answer. So we get x squared plus 9 times 3x plus 5. And we go ahead and we either area model that or distribute. Okay, so I get 3x cubed plus 5x squared plus 27x plus 45. And there are no like terms to combine. The next, f over g, order matters here. So we get f of x over g of x. F over g of x is equal to x squared plus 9 over 3x plus 5. And I can't, x squared plus 9 is a difference, the sum of squares. So I can't factor that. I can try it on the side with the big X. 9 is my C value, 0 is my B value. 3 times 3 gives me 9, but doesn't give me 0. Negative 3 times negative 3 gives me 9, but not 0, so this is not factorable. It's kind of hard to cross off the big X. So the domain, we're going to look at the bottom. What can't we divide by? We can't divide by 0, so we get 3x plus 5 is equal to 0. And then solve for x. Minus 5, we get 3x is equal to negative 5, divide by 3. So x is equal to negative 5/3. Or cannot equal negative 5/3. Okay, so if I'm going to just plug in a value for x, you have two choices. You can either look at what f plus g was, which was this, and plug it in, or you can plug in f of 4 separately. So I'll do it both ways. Okay, so I'm going to take what I had from above, x squared plus 3x plus 14, and I know that's equal to f plus g of x. And now we're going to plug in f plus g of 4. So I get 4 squared plus 3 times 4 plus 14. So 16 plus 12 plus 14, that's 42, is equal to f plus g of 4. Okay, alternatively, you can plug in f of 4 plus g of 4. So f is x squared plus 9. So that would be 4 squared plus 9 plus 3 times 4 plus 5. And I see I get 16 plus 9 plus 12. A lot of these numbers are familiar. Plus 5, which gives me 42. So either is right. Okay. Same thing for the f. We can plug them into f and then g, or we can just look at what we got right here. So I'm going to go ahead and use that. X squared plus 9 over 3x plus 5. And then I'm going to substitute the negative 1. So f over g of negative 1 would be negative 1 squared plus 9 over 3 times negative 1 plus 5, which gives me 1 plus 9, which is 10, and then negative 3 plus 5, which is 2, so this is equal to 5. Okay. All right, the next thing that we're doing is composition of functions. So this is when the result of one function is sent through the other function. The result of one function is the input for the next function. So it's written like this, and the little dot in the middle of the function is an operator, and it means composed of, and we say it f of g of x, okay? And so another way to think about it is saying the result of f is sent through g. And I personally like the function written like this instead, because I can see that I start in the inside. G of x is the input into f. Okay, so g of x is being the input into f. Okay, so first off, we're going to determine the domains, and then we are going to do f of g of x. Okay, so, and then g of f of x. So the domain for f of x is linear, so x is equal to all real numbers, and the domain for g of x is equal to all real numbers. So I'm not going to have a problem here with my domain when I put one function into the other. Okay, so f of g of x, f of, oh, it's an open circle, you have to be really careful, is equal to f of g of x, which is, so f, we leave, g of x is equal to x squared, right here, okay? And then now in f, I'm going to insert x squared in for x. So anywhere there's an x, so 2 times x plus 3, but instead of an x, I'm going to use x squared. So the function f of g of x, or if you can write it like this, is equal to 2x squared plus 3. And this is for, I have to look at my domains. There were no domain restrictions at all in either function. So in the end, this parabola is going to, x can equal all real numbers as well. Okay. So for b, or for the other way, g of f of x, we can write this as g of f of x. So we're starting with f of x is 2x plus 3. And then we're using that to substitute it into x squared. So something squared. And our new input is 2x plus 3. And that is it. So again, no domain restrictions. So the domain is all real numbers. The next one. We have the domain for the first is x, the inside has to be greater than or equal to 0. The domain for the second is x is equal to all real numbers. So first we're going to do f of g of x, which is f of x squared, and then f is the square root of x, but inside I'm going to input x squared. Take the square root and I get x. And I'm like, okay, wait, so x has to be, x squared has no domain restrictions. So I can put in any number right here and it'll work, right? Okay, any number, x squared. So is there any number that I can't, that would produce a negative number in x squared? I have to think about that because right here, I now have to think x squared has to be greater than or equal to 0. And I'm like, oh, but any number is greater than or equal to, any number squared is greater than or equal to a negative number. So when I square root, I get x is greater than or equal to 0. Okay, so, or plus or minus x, it's both. Because when you unsquare something, you get both. So x is equal to all real numbers. Okay, we're going to do the next one. So g of f of x, which is g of the square root of x. And then we're going to plug this into something squared. So it's the square root of x squared, which is just plain x. What do you notice about these? Actually, let's do the domain next. So the domain of the function, first off, I have to look at this beginning part. What numbers can't I plug in for x? Okay, I notice here that x has to be greater than or equal to 0. Otherwise, if I have something smaller than like -1, when I plug it in, I'm going to test this. If x is equal to -1, I'm going to have something like this, the square root of -1 squared. How do you take the square root of -1? You don't. So you're going to have to make sure that your domain says that the numbers that get plugged in right here are greater than 0. Okay, so there is a little bit of a restriction. It means that your line will only graph on the right side of the graph. Okay, and so let's write a little bit of rules about our, last thing. What did you notice about this last function? Notice that when I put in g of f of x and f of g of x, that we both got x. So when this happens, when you compose functions, and get just plain x, the functions are inverses. Okay, we're going to write a little bit more about domain. So the rules for domain. Okay, so you have to consider the domain of the initial function, because that initial function is going, the output to that initial function is going to be the input to the new function. So to make sure we get an output, next we're going to consider the domain of the composed function. So the overall function. So two places that you have to look for domain restrictions, in the initial function and in the composed function. What I want you guys to do next is try problem C, and then I will go over it. Okay, I got started. So the domain of x is all real numbers. The domain of g is x cannot equal 0. So we're going to do f of g of x. So f of 1 over x is x minus 4. So 1 over x minus 4. And I have to think, okay, so what numbers are going to break this part of the function right here? Well, that's when x cannot equal 0, right? So at this moment, we're going to be like, the domain is x cannot equal 0, okay? Next, we're going to do the g of f of x. So g of x minus 4, are there any domain restrictions here? So this is x can equal all real numbers, so I'm not concerned because it's always going to give me an output. So g of, so then I get 1 over x minus 4. Are there any domain restrictions here? Yes, I see x cannot equal 4. So, I know that the domain of f doesn't mess me up at all, but the compose function does, so I have to add that restriction in. So I get only this.